For this particular video, we're going to discuss a new way to measure angles. Up to this point in geometry and algebra, you've learned about measuring angles in terms of degrees, and the rotation of a circle being 360 degrees, and then of course that 360 degrees can be divided into individual parts. Very similar to a clock in that regard. Now, the thing about the degrees is it doesn't always give us the best unit of measure to do mathematical problems. So what you'll see is lots of industries like science, mathematicians, engineering want a more mathematical measure in nature, and that's where we bring in what's called a radian measure. Now, what a radian measure is basically the relation of the measurement of the radius to the arc length. You are familiar with the circumference, and since you know if we had a radius of 1, the circumference would be 2 pi. So for the arc length to go all the way around the circle with a radius of 1, we'd end up with a length of 2 pi units. Well, this is what we call radians. And basically what a radian is in short is basically here, if we have a radius, when the arc length actually equals to the radius itself, we have 1 full radian turn. So this arc length, and this arc length is usually represented by an S. Whenever we have the arc length actually equaling to the radius, then we have 1 radian measure. Now, we usually have RAD as a radian measure, but since it's usually written in terms of pi, relating back to its circumference, we don't necessarily write the RAD. But just to be sure not to get radius of the circle confused with radian measure and the RAD. So when our arc length actually equals the radius, we have 1 radian measure. Now, if you looked at this really closely, if we took another radian measure and another radian measure, we get about 3 of these just right before the half circle. And so if we went just a little bit more, we'd roughly have 3.14 radians, which you know is a good approximation for pi. So half of the circle is pi units. Now, we will probably spend some time in class discussing how to come up with this value. In short, however, if you know that a full circle is 2 pi for the circumference and it's 2 pi radians, then you would know a half a circle is pi number of radians as well. Now, we can come up with these values through the ratio of circumference and the arc length as a percentage of the circle, and when we divide that back by the given radius, we would have the radian measure, and you can see a little formula here. Now, you won't need to spend a lot of time calculating this. You will be given a degree measure either in terms of angle measurements, in terms of degrees, or in terms of radians, and many times we'll just be looking for you to convert back and forth. Now, the easiest thing for us to do from a conversion rate is use that semicircle. We know that 180 degrees is the same thing as pi radians, so we can come up with a ratio here to convert back and forth from degrees to radians and radians to degrees. So this is very convenient so that we don't have to go through the proportional relationship with the circumference and the arc length every time we want to calculate a radian measure. So if we look at sample problem number 2, we basically just have 2 simple little problems to get you in the habit of converting back and forth between the two. So use the little summary box above to help you do sample problem 2, part A and B, and then come back and check the solution. Okay, if we want to convert from degrees to radians, when I use my setup, I have 110 degrees. So I need to use the ratio that has the degree portion on bottom. And the reason I want to do that is from a unit analysis point, I want those degrees to basically cancel each other out. And when they do, I get 110 pi over 180. Now, you want to make sure that you reduce these all the way. So this is going to be the same thing as 11 pi over 18. So we can see that 110 degrees converts to 11 pi over 18. And of course, it's not necessary for you to put radians on the back end of it. It's kind of understood, especially being written in terms of pi. But if you wanted to put a unit of measure, you could use RAD in short. Alright, and if we want to go back the opposite way, here I have a negative angle. So I want to convert that back to degrees. To do this, I'm going to flip my ratio, because again, I want the unit of measures to cancel out. And the unit of measure that I really want to cancel out here is the pi value. So this is going to leave me negative 180 over 9. And that's going to leave me negative 20 degrees. And of course that degree symbol comes from the 180. So negative 20 degrees. Alright. Well, there's a quick introduction to Radian Measure for you, and a simple way to convert between angle measures and radian measures, degree measure and radian measure for angles. And so what you'll need to do is to become comfortable with these various measurements. And you can see here on the next page we have a nice little chart for you showing you all of the common degree measurements of a circle and their corresponding radian measurements. Now, I don't expect you to memorize these, but hopefully you'll come to know them very well just through working various problems with them. So we'll stop at that point right here, and you can use this next page of notes as a reference, and so you can see some common families of angles with the 30-degree angles, the 45-degree angles, and the 60-degree angles. And again, you'll get to know each of these angle types and measurements through use of working problems.